Very excited to introduce Adrian Mitchell, who's part of the Creo Software North American team. He has a lot of experience in productization. He's worked for Horizon North and Bone Structure, two Canadian companies that do prefabrication, I think mostly residential projects. And since then, he's been working with Creo. Creo is pretty amazing tool that helps architects and engineers and owners and developers to review using mass timber on their projects. Essentially, I'm probably not describing that the best way, but you can fill them in on that. So you're going to give us a presentation on the productization of mass timber, the key to mass market adoption. So excited to hear from you, and thanks for joining us.
Hey, thanks a lot for the introduction, Thomas. And it's an honor to participate in such an outstanding event. So again, my name's Adrian, and I'm the VP of Sales with Creo, as stated by Thomas. And I've spent the last 10 years of my career on the sales side of things in the construction industry, specifically handling off-site, modular, and kind of modern methods of construction, and selling and executing some of these projects around Canada. So I've been navigating these projects in a market that's, of course, dominated by traditional methods of construction and development. And without a doubt, right now it's a very exciting time for mass timber in Canada and around the world. We're seeing an unprecedented number of projects breaking ground all over the country, especially in markets like Vancouver and Toronto. And that being said, although there's a lot of growth in the mass timber space, it still represents a fairly small percentage of the overall market, as we know. And there are some things that we can do to better position mass timber and off-site construction methods to achieve meaningful and lasting market adoption. So that's what I hope to leave you with today. So the question that I'd like to ask is, well, why haven't buildings become productized in general? We know that there are limited niche markets where we have seen substantial growth in productization, specifically the modular construction market or volumetric modular. But there's still a lot of ground to cover on the timber side of things. That being said, we're making progress. One thing we can look at outside the construction industry is the productization that we've achieved in various other sectors, including things like vehicles and airplanes and electronics. They're all designed on modular platforms with standardized components. The big exception here is that, of all these big ticket items that we trust and that are highly evolved, we're still taking a very simple and non-productized approach in the way we develop and design most of our buildings. So in order to understand what I believe to be some of the root factors inhibiting productization, we should focus first, I think, on where construction projects start, and that's in design. So in order to address some of the significant factors impeding adoption of productization and off-site construction methods, let's take a high look at how traditional construction development industry conceives projects. So the design as a service model is a typical approach that the construction industry and development industry uses to develop a project. But it has not delivered the kind of innovation we've benefited from in other sectors. So it's true that we've seen noteworthy uptick in prefab methods, but it still on average represents less than 10% of the market here in Canada and in the United States as well. And despite substantial advantages to construction speed, quality control, and cost, the vast majority of construction is accomplished via traditional site-built framing or structural site-built methods. And this is especially true in the housing sector, where we're desperate for improvements in productivity. So what's design as a product? So design as a product has unlocked the power of incremental improvement. As we can see outside of the construction industry, numerous generations of revolutionary improvement in this regard have been applied to everything from automobiles, cell phones, computers, and it begs the question: what would design of a product look like if we'd applied it to architecture and construction and development, in 1909, like Henry Ford did it to automobiles? What would our building systems and processes look like today if we'd evolved them, over the last 150 years? So what I believe, based on my experience, is holding us back from mass adoption is the fact that we're treating too many projects as one-offs. And this revolves around the idea, I believe, of architecture and engineering as a service. So traditional conceptual design is about architecture as a one-off service. The opportunity for promoting mass adoption of modern construction methods starts at the product conceptual design stage. It's really difficult to take an engineered system or kit of parts and apply it to a conceptual design that wasn't conceived around that kit of parts and its limitations and opportunities, after the fact. So I believe the biggest opportunity here for us to advance productization and mass timbers is really rooted in the way we conceive projects and treat them as one-offs. So architecture as a service generally follows, 3 core steps. And the problem is not that traditional conceptual design, the problem is that traditional conceptual design leaves structural engineering too late in the process for productization to be effective. So what we want to do is we want to try to consider engineering limitations in the kit of parts, and consider that before we start conceiving our design or conceiving our massing and schematic. Because if we don't, we end up with a project that is more conducive to traditional methods. And I lived this problem when I was doing prefabricated systems at both Bone Structure and Horizon North. All too often, I would have potential clients and developers coming to me with developed schematic designs, and they were already too far down the design path. They hadn't been designed with a kit of parts in mind, and we were tasked with an impossible process, or trying to apply our system to a pre-designed scheme. And more than 99% of the time, those projects didn't move forward. So we need to take a look at how we conceive projects if we want to push forward. So why is mass timber so compatible with productization? Because I think this is the key here to the presentation, is why, unlike traditional materials and methods, should mass timber embrace productization in order to achieve scale. So architecture and design as a product is about creating a versatile kit of parts and pre-engineered systems. And these systems should be versatile enough that they can be used on more than one project. Does that mean these systems can't evolve and improve over time? No, but they should have enough flexibility that they can be used on a variety of projects for that building type. And the way we get there is the architect, working in advance with an engineer and manufacturing partner, develops a reusable library or kit of parts, which includes structural components, for example, mass timber, LVL or glulam beams, CLT panels for floors and shear walls and cores. And then once these components have been engineered and designed and thoughtfully put together, they can be used again on future projects, creating new efficiencies and also helping manufacturers create consistent and stable demand of materials. So this strategy really entails spending a little extra time in pre-con on the first project, and spending a little extra time coming up with a kit of parts. But the idea here is that once that time is well spent, once we have a great kit of parts, we don't have to do that work over again. We can reuse this kit of parts, and we can focus our time on coming up with better project outcomes and better plans and schemes, and also at improving incrementally that kit of parts every so often, perhaps every year or two. So Again, the goal here is creating the economies of scale that we know we need to really bring mass timber construction and developments into the mass market. Because we know if we continue to treat mass timber for legacy one-off projects, that we're not going to be able to create the economies of scale, everything from the manufacturing economies of scale to the trades and the talent we need to design, engineer, and build these buildings. We're not going to be able to create that fast enough and in a more meaningful way. So I would say like the iPhone or the Tesla shown in previous slides, having this refined kit of parts, we can imagine what a refined mass timber kit of parts would look like 100 years into the future, and really make that comparison to how we see a Model T rolling off the production line in the first productized, one of the first productized vehicles, to the Teslas and the modern vehicles we see today. And it's exciting to think where we could get with a mass timber productized kit of parts in the future. So why is mass timber so ideal? Well, it's ideal because it's a highly value added material versus stick lumber. So this makes it ideal for productization because if we use mass timber, we use these highly value added materials with a traditional construction method, well, it's not very feasible. I mean, traditional methods have resulted in landfills being 50 to 60% full of construction waste. And if we're paying a lot more for our material, it's not feasible to have that kind of waste. So we're adding a lot of value. We're preparing our material in the factories, in the mass timber factories, to spec by the architects and the engineers. Those factories are producing those standard components, and instead of preparing and cutting those components on a job site and then installing them, we're really just focused on installing them on the job site, which has substantial impacts on speed of construction. So also, we need to consider that mass timber is a highly value-added product that's produced in limited dimensions. So if we don't consider our supply chains, opportunities and limitations and strengths in the pre-con and in the conceptual design phase, we may be unknowingly, as architects, driving up, and engineers driving up costs unnecessarily by perhaps creating a one-bedroom apartment that's 6 inches too wide for the maximum size of a CLT panel, for example. The other factor as to why mass timber, is ideal for productization is because setting up a mass timber or an engineered wood product factory is very expensive. Now, if we can take that cost and spread it out over more standardized material, and really help those suppliers produce more of the same components, it really opens the door for these mass timber suppliers and producers to be able to make additional capital cost investments on advanced levels of automation, and then also to make additional production facilities and scaling up their existing facilities a lot easier from a capital cost and ROI standpoint. If we continue to just focus on one-off projects, it's a lot harder for facilities to scale up their efficiencies from an automation or semi-automation standpoint, because each job has completely different requirements, completely different kits of parts. Now, we can see what scaling up in automation looks like in other sectors, and how important it's been for us to develop and improve our quality of lives. We can see it in cars and telephones and computers, and like many of the complex value-added products we rely on as modern consumers, there's a massive opportunity to applying this thinking and this strategy to the way we build, and specifically the way we build with timber. So I'll move forward. So what does this look like? What does a workflow look like in a architecture and design as a product versus architecture as a service and a one-off? Let's give you a sneak peek as to how we address this at Creo software. But first, I'll maybe share, our vision at Creo, and what we're believing here at Creo is that we think differently about how the industry should conceive new projects. And this is because the status quo simply is not conducive to rapid adoption of productized building components like mass timber, modular, and offsite construction. So we believe that in order to achieve rapid adoption, we must address the way we design at the early stages, so the conceptual design stages, and that the way we challenge the status quo is by making our design tools practical and easy to use. I, for example, am not an advanced BIM or Revit user, but surely you'll see how I can effectively conceptualize and at a pretty high level of detail a mass timber project in a matter of minutes, and be able to test that project against potentially other concepts or other ideas that I might have, and get measurements using real BIM data against that result. Before I jump into a quick workflow example and demo for you guys, I'll explain a little at a high level how we develop our system and how we articulate data. So on my screen here, you'll see a few things. When we work with a mass timber or modular client to embed their system and kit of parts onto our platform and our software platform, we start by breaking down their system by primary and secondary load members specifically. So if it's a mass timber building, it may have columns that are glulam LVL columns. It may have beams, glulam and LVL, and it may have CLT walls, CLT floors. And so that's what we can see here, breaking down the components. And in doing that, we're taking a look at how those components can be used and what are the rules that need to be applied to those components so that we drop it into our AI-assisted design tool. We're not designing something that the engineers can't put their stamp on or can't approve. We're designing around the limitations of the system and each kit and each item in the kit of parts. So we can see here that we're considering spans, we're considering loads, and we're also considering things like core configuration. And on this specific example, we were considering MEP and HVAC access to each floor back to the core. So every project is different. Creo is not engineering and designing kit of parts. What Creo does is we articulate productized systems like mass timber and modular. So this is a quick window as to kind of the work we do with our clients in advance before a system is up and running on our platform. Essentially, we digitize kits of parts, and we take our clients' Revit or SolidWorks BIM objects, articulate those, and that can be for almost any building type. It could be for low-rise apartments, it could be for office buildings, it could be for student housing, anything that the architect, engineer, developer wants to use a kit of parts for. We can articulate it and work with our clients to follow the rules around that kit of parts and make sure that they're expressed accurately on our platform. So the demonstration that I'll run through you for today is an example of a pilot project we did with a company called Stora Enso. Stora Enso is one of the largest producers of mass timber in the world, based in Europe. And recently they observed some of the work we've been doing with an off-the-shelf product we have called Creo Modular, which is a volumetric conceptual design tool. And they wanted to apply it to their mass timber kit of parts for office buildings specifically. So Creo agreed to produce a proof of concept for them, and today I'd like to just give you an idea what that looks like. Now, keep in mind, this is just a pilot project that we did. It's in process for potential future development, but it does give you a good understanding as to how Creo can articulate productized mass timber kits and parts, and also what a workflow would look like for an architect, engineer, or developer trying to rapidly conceptualize productized systems. So I'll jump into that now. So here we're on the dashboard for Creo Design, and within Creo Design, I've got a ability to access the Store Enzo pilot project. So I'll start by clicking a new project button. Call this the CanBIM project. And the project we'll be demonstrating today will be for a commercial office. And immediately, this system is asking me for some general parameters of this project, and this is in metric, of course. I'm going to adjust that to 30 meter tall building with a target average room structural height of 3 meters, dead load of 2, live load of 3, and a fire resistance of R60. By setting these parameters, this will impact the rules and the kit of parts and the components used in order to conceptualize this specific example. So the first step is for me to select my site. I'm based here in Vancouver, British Columbia, so it's automatically defaulted me to near where I'm sitting in my office here in Mount Pleasant. I'm just going to choose a site for a potential project. And then I've got some standardized footprints that are conducive to the store office kit of parts that we've been provided with. I'm going to select a footprint that I think could work for this site. I'm going to choose this one. Zoom in on it a bit, and I can reposition this on my site and maybe even change some of the dimensions for my building footprint. I want to make sure I maximize the nice view of False Creek as well as some of the south-facing natural light. So I've repositioned the massing here. Once I'm happy with that, I can proceed to a next step, and Creo will begin to calculate potential solutions. So the next phase is to choose the platform that represents what we think is the best circulation solution. What's interesting about the circulation solution here is it's also the HVAC and MEP solution. So we can see the light gray area is not only how people will access all sides of each floor of the office, but it's also where our MEP system is going to sit. And this is important because the algorithm will actually design a structural solution that allows the MEP system to not be interfered by any structural components and provide direct access to the core. So generally what I try to do is I look at the one that has the optimal circulation area and the best, most direct path. And although this one has a low circulation area, I'm not too keen on the MEP complexity, so I'm going to choose this one.
So, Adrian, I just wanted to jump in.
Yep.
We're just bumping up on the end of our time here, and I wanted to have make sure we had an opportunity here to ask some questions and whatnot and have a conversation. But I haven't seen a demo of Creo before. It looks like a really interesting product, and I guess it's built around this concept of productization, right? So you have standardized components, whether they're CLT slabs or columns or wallums, as we talked about earlier today. Creo is coming out of Europe as a product. Are the market conditions a little bit different there? Or are you seeing in that market the fabricators start to standardize around a kit of parts concept, or is it more similar to here, where every project's a different solution?
Yeah, I mean, great questions. I think we're in the early days of that productization, and that's something that I'm spending a lot of time preaching, because it really can open up mass timber for the mass market, for middle class housing, for example, even affordable housing. Of course, Europe is quite far along. I'd say they're about 10 or 20 years ahead with regards to productization. But I think
and again, really alleviate the bottlenecks in production that we're starting to see as we get into this. So
that's right.
What do you think needs to be done to enable that in the market? Do we, as an industry, do we need to come together and agree on what that kit of parts should be? Or how do we even start this conversation with all the manufacturers and all the designers to say, hey, let's standardize on this. I guess there must have been some sort of similar movement when we decided on what a 2x4 was and a 2x6 was at some point, right?
Yeah, no, it's a great question. I mean, if I was a manufacturer, I would think that, there's a great opportunity for me to really take an initiative in that regard, and knowing the limitations and strengths of what I can produce better than anyone else, to really, put a kit of parts together and for the building types that we know there's a significant demand for, and really market that to the people designing these buildings, which are the architects, and really kind of feed them the ideal kit of parts that's going to drive down costs and increase production efficiencies without having too much of a detrimental effect on the architect's ability to, do their job, right?
Yeah.
But if I was an architect, I would also see, an opportunity to really, carve out a competitive advantage in what is a highly competitive space, and diversify my pipeline of projects. And knowing that if I productize, for a multifamily housing segment, and I do a good job, then I'm going to be able to drive a lot of future projects in my direction for people that want to use my productized system that I own. That's my IP, right? So it's hard for me to answer that straight, but I think it's a combination of architects and manufacturers taking a little bit more initiative in that regard.
Yeah, it's interesting. I mean, I think the shift is coming. We're already starting to see it, and I think it starts with those partnerships between the designers and the fabricators coming together and saying, how can we make something that's highly repetitive but can be adapted for various sites. So, and it was an excellent presentation. I'm sure there's lots of people that want to see like a fulsome demo here of Creo. If people want to get a hold of you, what's the best way to do that?
Yeah, people can get a hold of me by visiting Creo.net. That's our corporate website. I'm also available by email. It's adrian@creomodular.com.
Okay, excellent. Well, thanks so much, Adrian. Good to see you again, and hopefully we'll have the chance to catch up in person soon.
Yeah, looking forward to that, and thanks again for hosting me today.
Okay, take care.
Take care.